So let's look at this 11th question. It says, let A, B, M, N be natural numbers. A is greater than 1, B is greater than 1. Then some expression is given to you. A power M into B power N is equals to 144 power 145. Then the largest possible value of N minus M is. Very easy question. You can pause and try. See why A greater than 1, B greater than 1 is given. If something is given in the question, why? So that you don't make one of them as 1, so that you don't directly write that A power M and this is just 1 power. N can be anything, any natural number, correct? So let's say you take 1 and then you get to the answer immediately. That should not be possible, correct? Then what you will say, that M and this is N, correct? So M has to be whatever number at max what it can be, and you get to the answer. That is not possible. Why? Because 1 is not allowed. Now if 1 is not allowed, what you do now, you have to do prime factorization. This you understand, because product of this is coming out to be this. Now let's do the prime factorization. So 144 is what? Isn't 144 12 square? Isn't 12 2 square into 3 power 1? So whole square of this will become what? This will become 2 power 4 into 3 square. This is 144. Now see, so I write here A power M into B power N is equals to 2 power 4 into 3 square. You can also feel it like 3 square is what? 3 square is 9 and 2 power 4 is 16. 16 9s are 144. Then power 145. Now I have to maximize the value of N minus M. Now how do I maximize N minus M? I will want to make N as big as possible and M as small as possible. This is the scenario, correct? Now let's see how I do this. So I first write it like this. Why? Because I want to make N very big so that you see it correspondingly, correct? I'm trying to make N very big, so in with respect to corresponding to B, I have written 2 here, because 2 I can raise to more power for the same value. 2 can be of higher power than 3, correct? So now I try to make whatever is the biggest power of 2 here. So what I got is this 3 square into 145. So 2 into 145. So this becomes 3 power 290 into 2 power. Now 145 into 4. 145 into 2, 290. 290 into 2, 580. Now see. So I have gotten the biggest N possible, correct? Because I cannot take 1. I have taken the second largest number, which is second smallest number, which is 2, and 2 I can raise till power 580. So N is definitely 580. Now what can I take as M so that it becomes the largest one, or M I have to take the smallest number. So now see how I'm writing M. So what can I make here? There is no restriction that it has to be prime or anything. So this, instead of 3, it can be like 9 power 145. This also works. Now suddenly the value of M has decreased a lot, correct? Similarly, I can keep on going. I can even write this 3 power 290 is that big number, very big number, because there is no restriction on what can be that number A and B. It just has to be greater than 1. So 3 power 290 is that number, power 1 into 2 power 580. From here, if this is the value of A, correct, what is the value of M? So M came out to be 1. What is the difference between them? 580 minus 1, 579 becomes the answer. Understood? Simple. Okay, so this only had to be done. Then next, even easier, pause and try. See, it says for any natural number M, N and K such that K divides both. So K, this is the sign of divides. K divides M plus 2N and K also divides 3M plus 4N. Now what does this mean? Okay, now M, N and K all are natural numbers. Now see, if M plus 2N is divisible by k. Now if you know about anything about remainder theorem, what I can write it as? I can write it as whatever is the remainder when m is divided by k plus whatever is remainder when 2n is divided by k. Now both of these must come out to be 0. Correct? It should divide both of them. Now so from here what I got, because it is dividing it completely, so this remainder should be 0. That means k must divide m. Correct? Now this you got, k must divide m. Correct? Now next thing, from here what you can say, that k must divide 2n also. Why I'm not saying n? Because maybe it is like this, that this 2n is actually equal to 2 into let's say 5 and k is 10. Correct? So is k dividing n? So is 10 dividing 5? No. Correct? 10 is a much bigger number, but the multiplication of them, that is 2 into 5, is divisible by 10. Correct? So that means I can say that k divides 2n. I cannot say k divides n. Back you cannot go. If you want to increase this m into m, that is possible. 2n into 2n, all that, powers of these are possible. You can take powers of these, but you cannot take under root or something like that. Okay, then if you understand this, so from this we got this. Then the next thing is for 3m plus 4n to be divided by k. Now again same logic, but here you don't need to think much. Why? Because if I divide 3m by k, from the first one I have already ensured that k must be a multiple of m. So if k is a multiple of m, does not matter, then it will divide 3m also. Correct? Whatever is the value of m by k, that is a whole number, that means it is dividing. Into 3 will also be a whole number. Does not worry me at all. Correct? Now next thing what I can do is, basically from here I can say that 4n divided by k. Now 4n divided by k, can I write it like 2n into 2 by k? Now isn't 2n divisible by k? Correct? So this also is divisible by k. So from this I don't get any other conditions that I must take. If I have just ensured these two, then I am done. Understood? So if I have ensured that k must divide m and k must divide 2n, then I have essentially ensured the conditions. So what is the answer? B. K must divide m and 2n. There is no need for dividing 2m, 3m, all these are not needed. Even divisibility by n is not required. This is what you got. Then let's do the last one. So it says, this is a very good question. Okay, you will learn a lot from it. You can pause and try. It is not that difficult, but we don't usually think in this way. So it says what? Let Ln be the least positive integer such that 168 is a factor of 1134. Now it is not difficult at all. I will show you. See, the first case scenario is that 1134 is divisible by 168 power n. So first I need to find this value of n. Okay, where now this is the least value that will satisfy this. First let's find n, then we'll see the further question. Now can you find n here? What might be the possible value? Let's write the prime factorization. So I'm doing prime factorization here. 1134. What is this? What is this divisible by? See, of course I can divide it by 2. Correct? How many times this goes? 5 times. By 13 it goes 6 times, and then 1 remains with 14, it will go 7 times. Now 5, 6, 7. Correct? 11 and 7, 18. So divisible by 3, divided how many times? So this goes 1 time, then 2 remains with 26, 8 times, then 2 remains with 27, 9 times. 189. 189. Okay, then again divided by 3, so this becomes 6 and this becomes 3. Now 63 you already know, this divided by 3, this gives you what? This gives you 7, 7 and 1. Correct? So what you got? 1134 is equals to 2 power 1 into 3 power 1 2 3. Oh, I have to go one more time. So 63, that means this is 21, and then again if I go by 3, this becomes 7. So then 771. So what I got? 2 power 1 into 3 power 4, 1, 2, 3, 4 into 7 power 1 by 168 power n. Let's find 168 also. Now, so this is 168. How many times this goes? 2 times. So this goes 8 times, correct? And this is 4, correct? Then again divided by 2, this becomes 42. Then again divided by 2, this goes how many times? 21. 21 means what? 3, 7, 1. So what I got here? I got here 2 power 3, 2 power 3 into 3 power 1 into 7 power 1 whole power n I have to find out. Now what is the smallest value of n? So all of these must be covered, correct? Then only it can divide it, correct? So basically what I want is, what is the n is the least integer such that 168 is a factor of this. Sorry, n is here. Sorry, n is actually not here. It says what is the least value of 1134 power n. Sorry, so this should be n. Now what is the value of n such that this is dividing this number, correct? Now you are getting it. 1134 power n divided by 168 should give you a whole number. Now what can be this value? If this has to divide it, then everything that is here must be here also. If it has anything more, does not matter, correct? But it cannot have anything less than whatever is given here. Now 3 power 1 is here, 3 power 1 is there, correct? 3 power 4 you have, so you have extra, does not matter. 7 power 1 you needed, 7 power 1 you have, but you needed 2 power 3, but you have only 2 power 1. So what I can do? I can make it 2 power 3. How? If I take n is equals to 3. If I take n is equals to 3, can you see this will become 2 power 3, 3 power 12, 7 power 3, and then this will be divisible. So n is equals to 3. This is what I got. Now it says if m is the least positive integer such that 1134 n is a factor of 168m. Now see, now they have reversed it. So this is 168 power m. Which number is dividing this? 1134 power n is dividing it. But n value I have already found. What is the value of n? N value is actually 3. Correct? Now, so I write it here. 1134 power either n is equals to 3. So I raise it to power 3. So this becomes 2 power 3 into 4 3s are 12, then 7 power 3. Now above this what I have is 168 power, correct? So this is 2 power 3 into 3 power 1 into 7 power 1 power n. Now what do you think? Again everything that is here must be contained here, correct? Everything that is here must be contained here. Now 2 power 3 is here, 2 power 3 I already have here. 7 power 3 is required, but I don't have it here. But 3 power 12 is required, I have only 3 power 1. So what I can do? I can try to make this 3 power 12. How? If I take m is equals to 12. Now if m is 12, what you get? 3 power 12, correct? Now it is contained, and 7 also becomes power 12. You needed only 7 power 3. So that means completely divisible. So you have got the values of both m and n. M is 3, plus n is 3, m is 12. It is asking you what is m plus n. So m plus n is equals to 3 plus 12, that is equals to 15. Answer becomes D15C. Okay, I know this was little tricky for you, okay, but this is actually from CAT I think 24. So this is little calculator as in at this level, but the thing is the concept that is used here by using simple numbers here can be given to you in CSAT also. You understood the core concept that if this is divisible by this, then whatever is here must be here also. So that I have to ensure by raising the powers. Same thing when I take here, then I have to do it, correct? If they had taken easier numbers like 12 or 27, correct? Then the calculation would be much shorter, but the logic would be the same. Okay, so this is it. Thank you. Let's continue. This is question 14. It says how many factors of this something is written are perfect squares which are greater than 1. Okay, now we have seen questions like these. So what you have to do here is basically you have to make how many factors can you get out of this, that you remember 4 plus 1 then into 5 plus 1 into 4 plus 1, whatever was the powers that we used to do, correct? Now here it is asking you about the perfect squares, but it is saying greater than 1. So 1 is also a perfect square. That means eventually I have to remove this one, correct? Eventually I will have to remove this one and that will decide my answer. Otherwise I can do wrong, correct? Correct. Now how can you get 1? Basically if all powers are 0, correct, then it will become 1. So that case I have to eliminate, otherwise all perfect squares are fine. Now if I want the factor, let's say this is that number n which is 2 power 4 into 3 power 5 into 10 power 4. Now what can I write this? I can also write this as 2 power 4 into 5 power 4, 2 power 4 plus 2 power 4, 2 power 8 into 3 power 5 into 5 power 4. This is the value of that n. Now its factor will look something like this. M can be equal to what? What can m be equal to? Observe this carefully. What are the possible values? I want m to be a perfect square, correct? Now if I want m to be a perfect square, what can be the powers of 2? It must be a perfect square. For example, if I get 2 power 3 here, now can I get a perfect square out of it? No, correct? Because perfect square means what? That if I take its under root, I should get a whole number. Now if I take an under root and it is 2 power 3, under root means into 1 by 2, so it will give me 3 by 2 something root, correct? It won't give me a whole number. That is why it must be, while if it is 4 here, then you can see it will easily cancel out 1 time, 2 time, 2 square will become 4, correct? So I want here that here I should have in power perfect squares only, that is even numbers only. So now 0, 2, 4, 6, 8. These are the even numbers. This when divided by 2 also will give me a whole number. That is what I want. So 1, 2, 3, 4, 5 possibilities here, then into 3. Now what I can fill here? 0 I can fill, 2 I can fill, 4 I can fill. Not perfect squares, sorry, if I have told perfect squares, that is wrong. Basically I want even numbers here, so that when divided by 2 it gives me a whole number. So I am looking for even numbers here. So 0, 2, 4, 6, 8, 0, 2, 4, and then last 5 power can be 0, 2, 4. Why not 6? Because 6 is not available. Simple. Only till 4 it is available. How many possibilities here? How many ways can I fill this blank and this blank? How many ways? 1, 2, 3, 4, 5 into. This is 3, then into, then this is 3. Correct? We see this in permutation and combination also. How many ways can you fill these 3 blanks? Correct? So this becomes 5 into 3 is 15, 15 into 3 is 45. Now, don't be very much in hurry and take this. 45 would be wrong. Why it would be wrong? Because here power 0, power 0, power 0 yields 1, that I have to eliminate. That means 45 minus 1, 44 is the final answer. That is why 45 is also given in one of the options. Okay, then let's do next. Now what it says, how many pairs of mn of positive integers satisfy the following equation? Now see, whenever the question is like mn are integers and they satisfy some equation, always remember this is all about trial and error. Why? Because if you try to solve it using quadratic or anything, you will get fractions also, correct? You just want integers, that you cannot get directly through some equation. That is why you have to do trial and error, but how you do that, that is also important, that you learn. So basically m comma n are both positive integers. Okay, now it says m square is equals to 105 plus n square. Now isn't this 105 being equal to 105 being equal to n square minus m square. Correct? N square minus m square. Now 105 can be written as what? So this is actually n minus m into n plus m. Can you feel this? N minus m, n plus m. Why? A square minus b square. So n minus m into n plus m. Now I have to solve this. Now what can be these two numbers? So now just think of in what ways I can write 105. I can write it as 1 into 105. Is this possible? Yes, correct. Then the other possibility, it is divisible by 3, so I can write it as 3 into 35. Correct. Then is it divisible by 7? Yes, so it is divisible by 5 also, so this becomes 5 into 21. It is divisible by 7 also, so 7 goes 1 time and 3 remains with 35. This goes 5 times. Correct. So these are the possibilities that I got. Do I have any other possibility also? 3, 5, 7 is done. Correct. Already you have got 15 sevens are 105. Now if you want to try, what are the next number? Example 9 won't go, 12 won't go, 15. Will it go by 15? 15 into 7. Okay. So if I try to take this using 15, oh, that is already taken care of. 7 into 15 is already there. So that means once after this it will start repeating. It will be like 25, 21 into 5 and all that. Now these are the 4 pairs that you got. Now why I am saying that it has to exist like this only, not in the reverse order. Why? Because n minus m and n plus m, if both are positive, that means n minus m, whatever is the difference, will be less than n plus m. Why? Because both are positive integers. This is like 5 minus 3 will always be less than 5 plus 3. So here I must have a bigger number, and that is why I must write them like this only. How many pairs can you find? So basically each of them will give one solution. Correct. So basically if I want to solve first one, it will become n minus m is equals to 1 and n plus m is equals to 105. Then you can solve and get values of n and m. So one pair here, one pair here, one pair here, one pair here. How many pairs? You will get 4 pair of such numbers. Fine. Then next. Yeah, very simple, tricky question. Basically it is asking you, placing the following 2 digits at the right end of 4530 makes the resultant 6-digit number divisible by 6, 7 and 9. Correct. Now I want it to be divisible by 6, 7 and 9, all of them. What can be those 2 digits that I put after this? Now see, what can be these 2 digits that I can put here, I am calling them, let's say xy. What is the value of xy from these options that I put here, and it will become divisible by 6, 7 and 9. Now first thing, 9 is the easiest. Correct. So 9 if I want, see, 4 plus 5 is 9, 4 plus 5 is 9, 9 plus 3 is 12. Correct. Now can you see that 4 and 5 I can just cancel? If I am just looking for divisibility with 3, divisibility with 9, so 4 and 5 I cancel, only 3 remains. 3 plus xy is what I am getting. So I can put 3 in all of them and then find out the sum of them. Correct. Now 4 plus 5 is 9, 9 plus 3 is 12. Is it divisible by 9? No. So this option goes. Then 4, 2, 3. 4, 2, 3. So this is 6 plus 3, 9, possible. 7 plus 8, 15, 15 plus 3, 18, yes, possible. 9 plus 9, 18, possible. So one option only I could eliminate using 9. Now after this, let me put this. Yeah. Then after this, let's see divisibility by 6 if I want to ensure. So 3 already I have ensured, 2 is, all of them are even, so 6 is also not giving me the answer. That means the answer would be decided by 7 itself. Now how to find what is that number which is completely divisible by 7? Very easy. So basically what you have to do, see, 4530 xy, can I write it like this? Can I write it like this or not? Correct. I can write xy will be added here, this becomes that number. Now if I divide this by 7, it should be completely divisible. Completely divisible means what? That the remainder should come out to be 0. Now when can you have remainder 0? If this whole sum of remainders, whatever you get here, is equal to 7, then 7 divided by 7 will give you 0 remainder. Now what is the remainder in this case? This you can easily divide. So this goes 7 6 are 42, 3 remains with 33. This goes 28, 5 remains with 50. With 50 it will go how many times? 50 means 49, correct? So 1 remains with 10, it will go 1 time. 3 remains with 30, it will go 28, 2 remains. So 2 is the remainder. If you can't do this, just go by the long division method, you will get remainder as 2. Now, so what I am looking for, xy by 7 should be equal to what? I want the remainder 0. So I should be getting here what? What can I have as remainder? I can have 5 as remainder here. Correct? That is the only possibility. Why? Why not something like 12? 12 remainder is not possible when dividing by 7. So that means xy must give 5 as a remainder when divided by 7. Correct? Now you see the options, it is very easy. 5 remainder where you are getting. So 78, 77 only 1 remainder is there, not the answer. 42 completely divisible, not the answer. Then 96, how many times this goes? 7 goes 1 time, 2 remains with 26. This goes 3 times, 21, 5 remains. 5 is the remainder. 5 is the remainder that I am looking for. Answer becomes A, 96. Okay, that's it. Okay, so let's look at this question. This is question 17. Now, very simple question. It is asking you how many of the integers from 1 to 120 are divisible by none of 2, 5 and 7. It should not be divisible by any of these. Correct? Now, if I want to eliminate, so in total there are 120 numbers. Now, how much I should subtract? This I can call as divisible by 2 or 5 or 7. These numbers I want to eliminate, and this will be my final answer. Can you at least feel this? Feel this? I'm not able to see. Can you at least feel this? Okay. So 120 minus divisible by 2, 5 or 7 should be your answer. Now, there are in total 120 numbers. Out of them, 60 are even. Correct? Now, 60 even numbers will be divisible by 2. So, I must remove these 60 numbers. Okay, then this is because of 2. Then let's go another. So, now let's look at numbers which are not divisible by 5. Okay, but be careful here because you can do it directly also, dividing it by 5. Correct? By 5 you will divide 120 and you will get 24 numbers, but that won't be the ones that you should be counting. Why? Because 10, 20, 30, all these are still counted here, so we cannot count them twice. So just do a manual counting only. Now see, it starts with 0, 5 or 5, then next number would be 15. See, all even numbers are gone. Now I only have to worry about odd numbers with respect to 5 also and 7 also. So 5 is divisible by 5, 15 is divisible, then next is 25 is divisible. Why I am not caring about 20? Already covered in even numbers. Now, till what point I can go like this? So I start from 0, 1, 2, till what point I can go? I can go till 150. Can you feel this? Correct? So 95, then 105, then 150. So how many numbers? From 0 to 11, how many numbers? 0 to 11, 12 numbers. So I got here 60. Here I got 12 numbers that I have to remove. Then let's check for 7 also. So now in 7, first number is of course 7. After that, what I need to search? I need to search for those odd numbers which are not even divisible by 5. Only those I have to remove. Correct? Now, what are those numbers? So 14 won't be there. Correct? Even numbers I can anyway ignore. Then 7 into 3, 21. Yes. Then 7 into 5, 35. But 35 is already covered here. Then 7 into 7, 49. Yes. Then 7 into 9, 63. Yes. 7 into 11, 7 into 11 is 77. Yes. 7 into 13, 91. Yes. 7 into 15, 7 into 15 is 105, but 105 must have been counted. Correct. Where it would have been counted? Right here. 100 and 105 would have been counted here. Correct. So I will ignore that also. Next is, I had gone till 15 into 7. Then next is 17 into 7. What is 17 into 7? 119. Correct. 17 into 7. That I am talking about. 7 7s are 49. So 119. Is there any more number? No. So this is done. So now how many numbers? 1, 2, 3, 4, 5, 6 plus 1, 7. So you got 7 numbers from here. In total, how many you got? 60 plus 12 is 72. Correct. Then 72 plus 7 is equal to 79. So basically I have to remove how many numbers? I have to remove 79 numbers. So this becomes 120 minus 79. 41 becomes the answer. Don't get confused. Okay, at some places I saw that what they have done is basically later on they have also removed 1 and 3. Okay, so 1 and 3 you cannot remove it separately. Why you don't have to remove it separately? Because when I counted all the odd numbers after removing this, then I have already counted it. Okay, so now next, again, if n is a positive integer such that this, then the smallest value of n is what? Now, first of all, don't get scared by this. Okay, I have taken questions today which have some scary expressions. Okay, this and the next one also, but don't fear them. Just see what is written here. What is this? Is 7th root of 10. 7th root of 10 is essentially what? 10 power 1 by 7. This is what it is. Then into 10 power. Now this is again 1 by 7, but now square of this. So square of this will be what? 10 power 2 by 7. Then next is 10 power 3 by 7, and it goes on till 10 power n by 7. Now this is given to be greater than 999. Now if you don't know anything, at least you will know that you want to find out the smallest n. That means you will want here some small number which is just bigger than 999. Correct. Otherwise I can take n as 5000. Then will this satisfy? Yes. 5000 if I take, so 1 2 till 5000 I will go. Of course this is satisfied. Correct. Very big number, but that is not the point. I have to find the smallest number. So just bigger than 999. What is the power of 10? Can you think of? Isn't 10 power 3 1000? Correct. That is the closest one. So essentially the sum of all these, why I have to sum? Because this is multiplication of powers. So all of these will be added. So 1 by 7 plus 2 by 7 up to n by 7. Now this has to be equal to 10 power 3. Can you feel this? Correct. If this is the closest, 1000 is the closest power of 10 to 999. That will give me the smallest value of n. Correct. Now, so I start adding. This becomes, now 1 by 7 is common. What you will get here? This is 1 to n sum. So n into n plus 1 by 2. This, can I remove this? Eventually I have to make the power same. So can I make this power and this equal to 3 directly? Correct. So now what you will get is n into n plus 1 is equals to 7 2s are 14, 14 3s are 42. Now don't start solving the quadratic. Okay, n into n plus 1 is equals to 42. Can you think of any number? 42, what are the multiples? 21 into 2, no, not satisfying. Consecutive numbers I want. Isn't this 6 7s are 42? Isn't this true? Correct. And if this is true, that means n is equals to what? N is equals to 6. Is there anything difficult here? Huh? It's very easy. Okay, you just have to write the expression and see. Then next, this one also very easy. Try to pause and try. Again, some weird expression is given. Need not be scared about it. Now, see, it says what? There is a positive integer. So 3 power k plus 4 power k plus 5 power k is divisible by some a, where a is the largest positive integer that divides all the numbers of the form this. So this is some big number. Now a divides for any value of k. So what is k? K is any positive integer. So k belongs to any positive integer. That means 1, 2, 4, 5, whatever. Correct? Now, if this is true, a is dividing all of them and a is the largest such number that can do this. Now, can you at least feel that if I take a too large, let's say I take a as 5000. Now, if I put the values of k equal to 1, so wouldn't this become 3 power 1 plus 4 power 1 plus 5 power 1 by a? So this is what? 3 plus 4, 7, 7 plus 5, 12. So that means a must divide 12 also. Correct? A must divide 12. So a must be less than 12. Can you feel this? Can I have here 5000? No. But then it won't be dividing it completely. That means from here only I get that a is definitely less than or equal to 12. Not more than this. Now, if you look at any other power also, let's look at any other power. So this is power 1 I have already taken. Let's take power 2. So this becomes 3 square. That means I am taking here now k is equals to 2. So 3 square plus 4 square plus 5 square by a. Now, what is 3 square? 3 square is 9, 4 square plus 4 square is 16, 16 plus 9, 25, 9, 16 plus 9, 25, 25 plus 25, 50. So that means a divides 50 also. Now, can you think of any number that divides 50 and 12 both? Does 4 divide both? No. Does 6 divide both? No. Then what? 12, of course not. Then you go smaller and smaller. Then does 5 divide both? No. What divides both of these? What divides both of these? We'll get the 2 divides both of them. Is there any bigger number? No. That means 2 itself is the value of a. If you want, you can call this HCF of 12 and 50. What is the HCF of 12 and 50? 2. 2 is the biggest number that divides both of them. So, very clearly, you got that the value of a here is equals to 2. But that is just half the question. You have to find b also. Now, let's find b. In b, the expression given is 4 power k, okay, plus 3 times 4 power k plus 4 power k plus 2. This expression is divided by b. Again, I have to find b as the largest number. Now, before I start solving by brute force, what I must see, here I cannot simplify it because 3, 4, 5 have nothing in common. Their HCF is 1. But can you see some things common here? Some things are common here. Now, see how I am solving this. So basically, from the first two expressions, can I take 4 power k out? Yes. So this becomes what? This becomes 1 plus 3, that is again 4. 4 power k I have taken out. Here I will get 1, here I will get 3. 1 plus 3, 4. Now, isn't this 4 power k into 4 simply equal to 4 power k plus 1? Correct? Correct? 4 power k into 4 power 1, 4 power k plus 1 plus 4 power k plus 2. Isn't this equal to, if I take 4 power k plus 1 common, so what I will get? I will get 1 here and I will get 4 here. 1 plus 4 is 5. This is the value that you will get, 4 power k plus 1 into 5. Now, what is the value of k? Okay, that I have to find. Now, if this is divisible by b, then see, if k is very large, k is let's say 1000, then 1000 plus 1 into 5. So this is a very big number. It will be divisible by many numbers. But that is not the point. I have to find b which divides for any k. So I should take k small. Then only I will get the limiting case. So I take the smallest possible value of k here. Why? K is a positive integer. So smallest possible value of k is 1. So that means this becomes 4k plus 1 is 4 square. 4 square into 5 is 80. So that means 80 is divisible by b. Now the good thing here is that 80 is divisible by b. Now the next number that you try to take here, let's say you try to take k as 2, then this will become what? This will become, if I just separate this, so it looks like this: 4 into 4 power k into 5. Correct. Now if I take value of k instead of 1, I take value of k to be 2. So then what this will become? This will simply become 4 into 4 square into 5. So this is already 4 square into 5 is already 80. Correct. So basically every time I am increasing value of k by 1, I am just multiplying it by 4. That means if b is the largest number that can divide this, so b can be 80. Correct. For k is equals to 1, you are getting 80. So b, the value of b can be 80 here. Now anything bigger than 80 will not satisfy. Why? Because then k power 1 will not satisfy. But anything, once you have taken b as 80, now you take k is equals to 2, again that will be some multiple of 80 only. So every time it will be divisible. Now it is asking you, then a plus b equals to what? So 2 plus 80. 80 plus 2, 82. C becomes the answer. Okay, little solving you have to do. Okay, but if you understand this, how I have broken this down, then you can see it very easily. Okay, so now this, for natural numbers x, y, z, if this is equals to 19 and this is equals to 51, then minimum possible value of x, y, z is what? Now see, always we have talked about this, that if ever in question it is given x, y, z belongs to natural number or x, y, z belongs to integers, why the examiner keeps giving questions like these? See, understand, whenever you are solving any kind of equation, let's say linear equation, quadratic equation, whatever equation, you can get any real value. Correct. You can get complex values also, but not important. So you can get any value. Correct. And those you can solve like by brute force. But when the examiner gives you that this belongs to natural number or this belongs to integers, then you cannot follow those approaches. And that is why you have to do trial and error. You have to make cases and solve. And that is why they give questions like these. Basically there are very few cases that you have to try, but you have to try and get to the right answer. A typical way is basically this. So they will give you some x. Now this can be written in this form, that is a into b is equals to some x. Now this a and b are some numbers. If the value of x is known to you, for example, let's say if x is equals to 6, then what are the possible values for a and b? It can be like 1 into 6 or 6 into 1 or 2 into 3 or 3 into 2. Are there any other values? No. Correct. So you only have to check these 4 cases. Whatever case is satisfying other conditions also, that is your answer. But can you get this by any kind of linear or some kind of equation? No, you cannot get to this. That is why you have to try them. Now, so please learn this. Okay, it will help you a lot. There are so many questions in which they are using the same thing every time. Now see, this is a very similar question. Try to break it down in the same way. Now it says xy plus yz is equals to 90. So that means now xy plus yz is equals to 90. I take y common, it becomes x. I take y common, it becomes x plus z is equals to 90. Now, similarly, yz plus xz is equals to 51. So, I take z out, it becomes x plus y is equals to 51. Now, I really like these two numbers, 19 and 51. I really like them. Why? Because this is a prime number, and what is 51? 51 is straight away multiplication of two prime numbers, that is 3 and 17. So 3 into 17 is 51. That means they don't have a lot of factors. If I had 144 here, then I will get so many possibilities, correct? 12 into 12 is also 144. 16 into 9 is also 144. So then I have to think a lot. But they usually give you prime numbers or just one more, some multiplication of two prime numbers. So it becomes very easy. Now, here also it becomes very easy. Let's try to solve this. See this. Now, how can you get to 19 by multiplication of two numbers, which are natural numbers? Correct. That is 1 or 1, 2, 4 like this. Now, isn't this only possibility? Because 19 is a prime number. So 1 into 19 gives you 19. Now, can this 19 be here? No. Why not? Because then x plus z is equals to 1. Is that possible for two natural numbers? No. The smallest natural number is 1. So 1 plus 1 is 2. So it can never be 1. This is the only possibility. Straight away you get the value. One value you have already solved. Y is equals to 1. The other value is x plus z is equals to 19. These are your two values. Now you put this here, put this here. So what you will get, instead of z I am writing, or let z be as it is, and here what I will get is y is 1. So this plus x is equals to 51. Fine. Now what are the ways in which you can write 51? Okay, I will write all those ways. Now 51 has how many factors? 17 into 3, power 1, power 1. So how many factors? 1 plus 1, 2, 1 plus 1, 2, 2 into 2, 4. 4 factors. What are those? 1, 3, 7, 51. Sorry, 1, 3, 17, 51. Correct? These are the 4 factors. Now, I start writing. So let's say first possibility is 1 into 51. Now, is this possible? Let me write all possibilities and then we'll see. Okay, so now 51 into 1, then 3 into 17, then 17 into 3. These are all the possibilities. Now, is 51 possible? No. Why? Because x plus z is only 19. How can 1 plus x become 51? That means x is equals to 50. So, that means this is wrong. Correct? Then 51 into 1, but 1 plus x cannot be 1. This means x is equals to 0. Not possible. It is a natural number. Then 3 and 17 and 17 and 3 are the two things that you get. Now, this you can solve. So, if I take z is equals to 3, if I take z is equals to 3, that means x is what? X is what? If I put z is equals to 3, what is x? X is equals to 16. Correct? What was the value of y? So y is always 1. Then let's take the other value. So I take z is equals to 17. So z is 17. What is x then? X is 19 minus 17, that is 2. And what is y? Y is always 1. Now I have to find the minimum value of x, y, z. So let's find the value of x, y, z in both these cases. These are the only two cases possible. So then this becomes 3 into 16 into 1. 16 3s are 48. 48 into 1 is 48. Then 17 2s are 34. 34 into 1 is 34, which is giving you minimum. This case is giving you minimum. And what is that value? The minimum value? 34. 34 is the answer. Simple. Not so simple if you don't understand all this, but this is a very, very doable question. Okay, so whenever you get numbers like these, don't get scared of them. Here, if they are given in some product form or something, it is much better if you have prime numbers or numbers that are almost prime or have low factors. Then you can solve it very easily. Okay, that's it. Thank you.